So hopefully you just watched the previous video and you saw the horse problem, because now we build off of that. We said there were 8 horses, but you only needed to order 3 of them. There's a formula for that mathematically. And if you're asked to order n elements, but you only want the, so you have to, you're given n elements, but you only have to order r of them, right? So in the last one, we had 8 horses, but only wanted to order 3 of them. All right. So we only wanted to put 3 of them in order. The formula, that's still the 8 factorial from the last problem. And on the bottom, it's really 8 minus the 3 that you want to put in order, leaving you with the 5 factorial. So in the last problem, we talked about 8 factorial over 5 factorial. And again, we did the calculation in the previous video. But this formula will help you solve problems when you need to put things in order. And a range is another way to put things in order. Now, I do want to caution us here. These letters, now, if I write A, B, what I'm actually going to do here is I'm actually going to write down all of the possible outcomes here. A, C, B, A, B, A, C, A, C, A, B, I'm sorry, I already have that one. About A, B, C, A, C, B, A. All right, we got a couple more coming in. Let's do B, A, C, A, C, A, B, A. Well, B, C, A, C. Sorry about that. All right, so essentially there are 12 ways to order these letters. Now, this doesn't quite fit our formula of 4 times 3 times 2 times 1. The 4 factorial piece, if you notice 4 factorial, 4 times 3 times 2, that's actually 24. So if you were given 4 different pieces of information that you needed to order, if these letters were A, B, C, and D, the answer would be 24 right off the bat. But notice, we have this repeated information. There is an A in there twice. We expected to get an answer of 24, but we really only got an answer of 12, because we actually wrote them all out. So my question to you is, how are these two numbers related? We expected to get 24, because anytime you order 4 things, you should get 24. But when we repeated an A twice, we got an answer of 12. So I want you thinking about that, because we're going to look at a very similar question. We're going to repeat the letters a little more often. So this, so here we have, you could write A, E. That's obviously 1. Here, A, B, A, B, A, and then B, A. All right, these are that's actually all of them. There's not another different way to write those combinations. So again, we had 4 elements. Anytime you order 4 elements, you think 4 factorial. All right, that's one of the ideas we've learned from this lesson. But when some of them are repeated, we're not getting this answer of 24. We are, in fact, only getting this answer, we're getting this answer 4. So my question to you, how are these numbers related? All right, and if you go back to the previous slide, obviously you could divide this by 2 and you get the right answers. Now, the problem is here, if you divide by 3, you don't get the same answer, because 24 divided by 3 is actually 8. So this dividing by just 2 isn't quite enough. And the correct idea is, well, what if we divided by 2 factorial? 2 factorial is still 2. 3 factorial would now be 6, and 24 divided by 6 is 4. So I'm hoping you're starting to see a little bit of a pattern here. So this idea, again, yet another formula. There's a lot of formulas in this section. If you are asked to order n elements, all right, but there are some repeated elements, all right. say one element was repeated x times, another element was repeated y times, that's the following formula. This is your permutations formula on the top. All right, and because some of them are being repeated, you have to divide out what's being repeated. If something was repeated x times, then you divide out x factorial. Another element is repeated y times, divide out y factorial. And I'm going to show you yet another example, a little harder than the first three, where it's not possible to write out all these combinations. You would likely make an error. But I know if there's 2, 3, 4, 5, 6 letters in banana, all right? So if I had 6 different letters, the answer would be 6 factorial. Wouldn't have to do any more work than that. But some of these letters are repeated, like the A. The A is repeated 3 times. The N is repeated. Twice. So I had 6 factorial. That's going to get me the total number. If they were all different letters, the answer would be 6 factorial. You wouldn't have to do any more than that. But because there are 3 repeated A's, we have to divide by 3 factorial because an A is repeated 3 times. We're not done dividing though. We're also going to divide by 2 factorial because the N is repeated twice. So if I had to do this out, I like to do these without a calculator, because finding the factorial button on a calculator takes too long for me. So I know the 3's cancel out, the 2's cancel out, 2 goes into 4 2 times. So 6 times 5 is 30, times 2 is 60 different ways. So again, knowing the formula is going to be way handier than trying to write out all the letters in banana 60 different ways. Okay, so moving forward, we've talked a bunch about permutations, and that is when order is important. A combination is a totally different idea. A combination is when order is not important. You can, you are electing 7 members to a council, all right, out of 30 people. The order you pick those people, and they all have the same responsibility. You're picking players for a team, right? All of the players in the team have the same. They're all working together. The order that they're out there doesn't matter. There are several different ways you will see where combinations apply. Winning the lotto is a combination because the order of your numbers on your lotto ticket doesn't matter. So when order is not important. So let's say we have 5 players for our 3-on-3 basketball tournament. How many different teams can you put on the floor? All right, so let's actually work this out. Let's call those 5 players A, B, C, D, and E. And we are going to pick 3 of them. Now, A, B, C is a possible team. But the problem is, I couldn't write BAC because that's the same team. All right, so switching the order of those 3 is not going to be considered a different team because having the same 3 people out there is still the same team. So let's do A, B, D. That's a different team. A, B, E. That's a different team. All right, how about we'll do A, C, D, A, C, E. How about A, D, E? No. Okay. Well, let's do some teams that begin with B. We'll do B, C, D. B, C, E. B, D, E. And let's see. The last team, I think, is C, D, E, and I can't come up with any more. All right, so let's build on what we already know. So the answer to this problem is 10. All right, but the question is now, I don't want you to have to write out all the possibilities every time. I want you to have a formula for